Okay, today we're going to talk about sequences. We're going to talk about two different types of sequence. First one is arithmetic, and the second one will be geometric. And I'm going to try to spell the words right, but I'm not very good at spelling, so if I don't have them quite right, you can look them up. But we have arithmetic and geometric. Okay, so first off, a sequence is simply that you have a set of numbers in order. So for the example, if I have 1 followed by the number 2, 3, 4, etc., this is what we call a sequence. It's a set of numbers. They have a pattern. The pattern here is we're going to add 1, and that's how you get to the next number. So anytime you have a pattern of numbers, you have a sequence. We have two specific types of sequences that we study more than others. That doesn't mean there's not other sequences, but we have two that we like to work with. One is called arithmetic, one is called geometric. Arithmetic, the pattern is addition. So an example would be the one I just had here. 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, plus 1 is 5. We're simply adding every single time. Geometric, on the other time, is a pattern of multiplication. So you could start with 1, and then when you multiply by 2, you get 2, and you multiply by 2 again, you get 4, and then you get 8, and then you get 16, etc. Okay, so 2, arithmetic is addition, a pattern of addition. Geometric is a pattern of multiplication. So we want to know how could we figure out the order of the numbers if we didn't have them all, because these patterns go on forever. So a couple definitions. First off, we have what's called a sub 1. A sub 1 is the first number in your pattern. We always have to start with somewhere, and most of the equations that we're going to be coming up with are going to need to know what that first number is. So the first number is called a sub 1. In this case, it's the number 1, as well in this case. It's whatever the first number in your pattern is. Often we want to know what the last number in the pattern is. Okay, the last number we denote as a sub n, otherwise known as the nth number, which brings me up to the other definition. N is any number in the pattern. Okay, so it's the nth term. If I counted these, there's 1, 2, 3. Well, let me do this one so you don't have the same numbers. 1, 2, 3, 4, 5. The fifth number in this term is 16. So we'll denote this, the first term, second term, third term, fourth term, fifth term. This is what n is. Okay? N is the number of the terms. Okay? So we got first term, last term, and the number. In addition to that, we have a couple other special cases. In arithmetic, we have what is called d, and this is known as the difference. That is the number that you're adding every single time. So in this case, we're adding 1 every time, so d would be the number 1. We define it to be any number subtracted by the number before it. Okay, so any number, a sub n, subtracted by the previous number, which is a sub n minus 1. So let's say if we wanted to know what the difference is here, we could do 2 minus 1 is 1. And it should be the same no matter which two numbers we do, as long as it's a number and its previous number. So 4 minus 3 is 1, 5 minus 4 is 1. If we kept going, 6 minus 5 is 1. It doesn't matter as long as you take any number minus its previous one. So that's what d is. On the geometric side, we have an equivalent that's called r, and that's that number we multiplied every single time. Okay? And this stands for ratio. It is defined as any number divided by its previous number. So ratio is any number divided by its previous number. So in this case, our pattern was multiplied by 2, so r should be 2. And we take any number, say 2, and divide it by the previous number. So 2 divided by 1 is 2. And it works just like it does for addition in any case. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. So in all cases, we get 2. And as an important note, that for geometric, the entire pattern is only multiplied by 2. There are no other rules involved here. And for addition, the entire rule is add 1. So it doesn't matter where in the pattern you are. In the case of arithmetic, the difference is always the same. In the case of geometric, the ratio is always the same. So what we want to end up doing is we want to be able to define any number. We have two different definitions. We have what's called recursive. R-E-C-U-R-S-I-V-E, and explicit. Now, recursive means that it's a rule that if I give you a number, you can tell me the next number in the series. Explicit means that I don't need to know the previous number. I could just always come up with any number no matter what. Now, recursive is handy if we have a pattern, like say I want to know what the next number right in here is. Well, our pattern is just add 1 to the previous number. And we're going to write it like this. Our number a sub n is going to be our previous number, a sub number n minus 1, plus whatever that difference is. So in this case, the difference is 1. So our pattern is going to be our next number is the previous number plus 1. So let's try it. If I had 4 and I add 1 to it, I get 5. That's what it says. Our previous number, which was 4, add 1 to it, I get this number. And we can do the same thing. Our previous number, 5, add 1 to it, and we'll get our next number, which is 6. So that's what our recursive definition for arithmetic looks like. When you do problems, typically the only thing you're going to replace is d, and the rest of this pattern stays the same because we're always going to say the previous number and the next number. But you can replace d once you figure out what your difference is. Over here on this side, it's going to be similar. Our next number is going to be the previous number times the ratio. We write it like this, that it's going to be our ratio r times a sub n minus 1. Okay? So it's going to be the ratio times the previous number is our next number. In this case, our ratio is 2. So if I take any number, say 8, that's a sub n minus 1. We're going to multiply it by 2. You get the next number in the series, which is 16. And we could keep doing this, and we take 16, and we're going to go ahead and multiply that by 2, and you get 32. So the next number in our pattern would be 32, and that's all this says. So these are really good if you have almost the numbers that you want. But what if instead of wanting this number, this number, this number, I want the 100th number in the series? So I want to go way off in the future, and I want to know what the 100th number is. Using the recursive definition, you first have to figure out what the 99th number is, which means you need to know the 98th, and the 97th, and the 96th, and the 95th, and all the way back to the first number before you can come up with this 100th number. Well, we don't always want to do that. Sometimes we want to know what's going on without having to get that far. So we're going to look at some patterns here. So if I want to know this pattern, I need to always know where I'm starting. So a sub 1 is going to be really, really, really important. So we're looking for a sub n, and I need to start with a sub 1. But here's what happened. I start with the first number, and I added 1 to it. And then I added 1 again. And then I added 1 again. And I added 1 again. So I'm repeatedly adding 1. So in this case, I'm going to be repeatedly added the difference. So our nth term is going to be taking our first number and adding the difference, but now I got to decide how many times I'm adding the difference. Well, most people would say, well, it must be n times. And that's really close, but let's see what happens if we do it. We're saying 1, 2, 3, 4, this is the 5th number in the series, so if I say that I'm adding 1 5 times, I've gone once, twice, 3, I've actually only added it 4 times, because you don't add it to come up with the original term. You only add it to come up with the second term, the third term, the fourth term, and the fifth term. So instead of adding it n times, we're going to add it n minus 1 times, 1 less than whatever n is. So if I want to know what the 100th term is in this pattern, I've added our difference only 99 times. I've had it added 100 times. That's why it's n minus 1. So what this is saying is that if I want to know the 100th term, that would be denoted as a sub 100. All I need to know is our first term. In this case, it's the number 1. I need the difference, which in this case we decided was 1. And I need to then multiply that 1 by 100 minus 1. Okay, n being 100. And if we went ahead and did the arithmetic, you're going to get arithmetic here. You're going to get 100 minus 1 is 99, times 1 is still 99, plus 1 is 100. And of course, in this pattern, the 100th number would be 100. Now, in other patterns, it's much more complicated and it wouldn't be so obvious. So this is a really helpful formula. So the explicit formula is always going to be that our number, a sub n, the number in the pattern that we want to find out, is going to be the first number plus the difference times n minus 1, n being the number we're looking for. So if we're looking for the 100th number, we'll put in n is 100 right here. And we're going to do the same thing over here with the geometric. So just like with arithmetic, we're going to find our a sub n, and it's going to start with our first number, because we always have to know where to start. And what are we doing right here? Well, we're multiplying by 2 repeatedly. So we're going to start with our first number, we multiplied it by 2, and multiplied it by 2 again, and 2 again, and 2 again. So we're going to start with our number, and we're going to multiply it by 2. So we're going to go ahead and multiply this by r. Okay? But what we need to know is how many times we're multiplying it by r, and we denote that with an exponent up here. So most people would assume that maybe it's n. So let's try it. If I multiply by 2, I do it once, twice, 3, 4 times, but this is the fifth number. So just like it was with arithmetic, we don't want to have the number 5 here. What we want is the number 4. So instead of the nth term, we're going to multiply it by the n minus 1th term. Okay? So the ratio, the number of r's we have, is not n, but n minus 1. 1 less than whichever number term we're looking for. So in this case, if we wanted to find the 100th term, we would want to find a sub 100. That would be our 100th term. We need to know our first term, which in this case is the number 1. We need to multiply it by a ratio, which we said in this case was the number 2. And then it's n minus 1, n being 100. So we would go ahead and we're going to multiply this by 1. Well, that doesn't change it. And we need to know what 2 to the 99th is. That's an awful lot of 2's. This is not 2 times 99. This is 99 2's all multiplied together. This is a very large number, so I will let you use a calculator to find the answer, because that is a very large number. This is 99 2's all multiplied together. That's what 2 to the 99th is. But when you did it, that would be your answer. So I hope this is helping you out. This is, again, arithmetic. This is a pattern of addition, and geometric is a pattern of multiplication. If you have any questions, make sure you ask.